Welcome to our countdown of the top 10 ways the world could realistically end due to something happening in outer space. We're talking about cosmic catastrophes that could wipe out humanity and leave our planet a smoldering ruin. This video is not for the faint of heart, so buckle up and let's dive into the cosmos. We're going to explore the most terrifying ways the universe could snuff us out like a candle in the wind. Imagine this. You wake up one morning, go to grab your cup of coffee, and as you glance out the window, you see it, a colossal metallic disc hovering over your city. It's an alien spacecraft, and it's not here for tea and biscuits. A technologically advanced civilization could wipe us out without breaking a sweat, perhaps with nanobots that devour our biosphere, or maybe a weapon that disrupts our planet's magnetic field. The possibilities are as terrifying as they are endless. And the scariest part, we'd be utterly outmatched. Imagine trying to fight off a grizzly bear with a fly swatter. Maybe these hypothetical aliens would be benevolent, eager to share their knowledge and technology, or maybe, just maybe, they'd be more interested in our resources than in us. Remember the dinosaurs? They met a rather abrupt end thanks to a massive asteroid that slammed into our planet with the force of 1 billion atomic bombs. Now, you might be thinking, but that was millions of years ago. We have telescopes now. We can see these things coming, right? And yes, we've gotten much better at tracking potentially hazardous asteroids. But the truth is, space is a big place, and there are still plenty of space rocks out there that could sneak past our defenses. Even a relatively small asteroid, say a few hundred meters across, could cause widespread devastation. The impact would release an unimaginable amount of energy, triggering earthquakes, tsunamis, and wildfires that could engulf entire continents. Scientists are working on ways to deflect or destroy asteroids before they reach Earth. We're talking about giant lasers, nuclear weapons, and even spacecraft that could nudge asteroids off course. Let's talk about gamma-ray bursts, shall we? These are among the most powerful explosions in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. Now, these bursts originate from distant galaxies, billions of light years away. The vast majority of gamma-ray bursts are harmless to us, their energy diluted by the vastness of space. But here's the catch. If a gamma-ray burst were to occur relatively close to Earth, say within a few thousand light years, and if, and this is a big if, the burst were pointed directly at us, well, that's when things get a little dicey. Gamma rays are incredibly energetic, and they interact with matter in a rather unpleasant way. They can ionize atoms, stripping them of their electrons and creating a cascade of high-energy particles. The gamma rays would essentially fry our atmosphere, stripping away the ozone layer that protects us from harmful ultraviolet radiation. The good news is that gamma ray bursts are incredibly rare events, and the chances of one occurring close enough to Earth to pose a threat are astronomically small. Chapter 4. Supernova Explosion. Supernovae are the grand finales of massive stars, the explosive deaths that scatter star stuff across the cosmos, seeding the universe with the elements for life. But if a supernova were to occur too close to home, it wouldn't be nearly as beautiful or beneficial. One such neighbor is Betelgeuse, a red supergiant star in the constellation Orion. If Betelgeuse were to explode, and if, and this is another big if, the explosion were oriented in such a way that the full brunt of those particles were aimed at Earth, well, let's just say we'd be in for a rough time. The radiation from a nearby supernova could disrupt our planet's atmosphere, deplete the ozone layer, and bombard the surface with enough energy to trigger mass extinctions. But don't lose any sleep over Betelgeuse just yet. Astronomers estimate that it's still got tens of thousands, if not hundreds of thousands of years left before it goes boom. Chapter 5. Rogue Planet Collision. Out there in the vast expanse of space, beyond the familiar orbits of our solar system, lurk rogue planets, celestial nomads, cast adrift from their parent stars, wandering the cosmos like cosmic tumbleweeds. Now, space is astonishingly empty, so the odds of a direct hit are thankfully astronomically low, but even a near miss from a rogue planet could spell disaster for our planet. Its immense gravitational pull would wreak havoc on the orbits of the planets, including our own. Earth could be flung out of the habitable zone where temperatures are just right for life as we know it. Chapter 6. Solar Flare. Our sun may seem like a benevolent ball of fire providing us with light and warmth, but don't let its cheery disposition fool you. The sun is a volatile beast, capable of unleashing bursts of energy that could make a nuclear bomb look like a firecracker. Most of the time, these flares are harmless, their energy deflected by Earth's magnetic field, resulting in nothing more than a dazzling display of auroras at the poles. But every once in a while, the sun throws a real tantrum, unleashing a massive solar flare, a coronal mass ejection that sends a wave of charged particles hurtling toward Earth at millions of kilometers per hour. A direct hit from a major solar flare could knock out power grids across continents, plunging entire nations into darkness. Imagine a world without electricity. No lights, no internet, no refrigeration. The good news is that scientists are working on ways to better predict and prepare for solar storms, developing early warning systems and hardening our infrastructure against their effects. Chapter 7. Black Hole Encounter. Black holes form when massive stars collapse at the end of their lives, their cores crushed under their own immense gravity until they become infinitely dense points, singularities, in the fabric of space-time. Their gravity is so strong that nothing, not even light, can escape their grasp, hence the name black hole. If a wandering black hole were to pass too close to our solar system, its gravity could disrupt the orbits of the planets, sending them careening off into the depths of space. And if Earth were to get too close to a black hole, well, let's just say it wouldn't be pretty. As Earth approached the black hole, the gravitational pull on the side of our planet closest to the black hole would be much stronger than the pull on the far side. This difference in gravity, known as tidal forces, would stretch Earth out like a cosmic piece of spaghetti, a process aptly named spaghettification. Chapter 8. Cosmic Radiation. Space may seem like an empty void, but it's actually teeming with invisible dangers. High-energy particles, zipping through the cosmos at nearly the speed of light, known as cosmic rays. Now, Earth's atmosphere and magnetic field act as shields, protecting us from the brunt of this cosmic radiation. But some of these high-energy particles still manage to get through, and they can interact with our cells, damaging DNA and increasing the risk of cancer. For the most part, the levels of cosmic radiation we experience on Earth's surface are relatively low, not much of a concern for our health. But if we were to venture beyond our planet's protective embrace, say on a long-duration space mission to Mars, we'd be exposed to much higher levels of radiation, posing a significant health risk to astronauts. So while cosmic radiation might not be the most dramatic way for the world to end, it's a reminder that even the seemingly empty vacuum of space can harbor hidden dangers. Chapter 9. Galactic Collision. Our Milky Way galaxy is on a collision course with our nearest galactic neighbor, the Andromeda Galaxy. Mark your calendars, folks, it's going to be epic, but don't worry. You've got plenty of time to prepare. We're talking billions of years from now. Now, galactic collisions might sound catastrophic, but they're actually more like cosmic waltzes. Galaxies are mostly empty space, so the chances of stars actually colliding with each other are slim to none. Instead, the two galaxies will pass through each other, their gravity distorting their shapes, stretching out long streamers of stars and gas, like cosmic taffy. But while the stars themselves might not collide, the gas and dust between the stars will stars. Chapter 10. Vacuum Decay. Now let's talk about the ultimate cosmic reset button, vacuum decay. This one is a bit more on the theoretical side, but it's also the most mind-bendingly terrifying way for the universe to end. It's a scenario where the very fabric of reality unravels, and it all starts with quantum mechanics. You see, in the quantum world, nothing is ever truly settled. There's always a chance, however small, for things to spontaneously shift, for particles to pop in and out of existence, for the laws of physics as we know them to break down, and one of these quantum quirks is the idea of a false vacuum. Imagine the universe like a vast cosmic ocean. Outro Cosmic Perspective. Thanks for watching our countdown of the top 10 ways the world could end from outer space. Remember, while these scenarios are fascinating, they're also extremely unlikely to happen anytime soon. The universe is a vast and wondrous place, full of beauty and wonder, and for the most part it's a pretty safe neighborhood. Don't forget to like, subscribe, and hit the bell icon for more cosmic content.